Okay, right. This talk is JavaScript WTFs. It started off as JavaScript Gotchas, but I found so many weird things that Gotchas just doesn't cover it. That's me, Ashik. That's my website. That's my email. That's my Twitter. Right. So without further ado, let's get right into it. The talk is essentially going to be a humorous look at various oddities of JavaScript. JavaScript is written by a mad genius, pretty much, called Douglas Crockford. He's a genius, but he's also mad. That's why there are all these weird issues around JavaScript. At least that's my theory, anyway. Right, so the first weird thing, chain assignment. Many languages would actually support all of this. JavaScript also does. JavaScript seems very flexible in allowing a lot of different things to happen. Whether that thing actually has side effects or not, that's another issue, but it usually allows various types of declarations and statements. So in the first line, we can see we've got a variable initialized to 2. In the second one, we can see we've got var a and var b, and a equals b equals 2. So after those two lines run, both a and b will be 2, and they will be local variables. On the third line, we have var a equals b equals 2. And at the end of this, both a and b will both be 2, but there's a problem here. The problem is that b will now be global. And the reason it will be global is that anything you use without declaring it up front is added to the global object. And within a browser, that usually means document.window. So when we run this, what's going to happen is that since b hasn't been declared, as in we don't have a var b anywhere, b is going to be a global variable on document.window with a value of 2, and a would be a local variable with a value of 2. Right, so the solution is just don't do it. Avoid chain assignments in JavaScript during declaration. It's fine once all variables have been declared, but up front, when you're declaring it, don't do chain declaration and assignments. Simply, well, it's supported as in JavaScript will allow you to do it, but it will make the things on the right hand side global. Right, the next weird thing, hoisting. JavaScript kind of lifts all declarations to the top of a function, but the assignments are kind of forgotten. Let's look at that with examples. Let's say we have this bit of code, right? We've got a function called fun, and in the first line of that function, we are doing console.log a. In the second line, we're actually declaring a, doing var a equals 20. In the third line, we're doing console.log a. Now, when we run this, what's actually going to happen is that the first log is going to log undefined. It will literally log undefined in terms of well, what you see in a console in Firebug or Chrome or something. Right, and it makes sense because at that point you haven't actually declared a, because var a equals 20 comes after that. And on the third line, you can see that it logs 20 as expected. However, this undefined is actually different from not being defined. A at that point is actually defined with the value of undefined rather than not being defined, if that makes sense. Well, it's JavaScript. Right. And we can prove that by doing this. If we do a console.log a, that logs are undefined because it's not been declared. And then and there we do console.log b. Instead of logging undefined, it actually throws an exception. Right? So we can see that a and b is different here. A has not been declared on the first line, B has not been declared on the second line. So what's the difference between A and B that A logs undefined and B throws an exception? Well, that's where hoisting comes in. What JavaScript does is it takes all the vars in the scope and JavaScript has function scope, so each function has its own set of local variables, if you will. It takes all of the local variables, like say var a, and it lifts that as if it were the first line of the function. So that is essentially the same as saying var a on the first line, doing console.log, and then doing a equals 20. Right. Since we don't have a var b anywhere, b is actually not defined, and that's why it throws an exception rather than logging undefined. So that's fun. Right. More on hosting. This is, well, some code you might run into pretty much day in, day out, where we've got a var I at the top of the function, but we've also got a var I inside of the for loop. Now, if you were writing something like C# or something, this would be perfectly valid, possibly, because the for would have its own scope. In JavaScript, the only scope is function scope. Okay, apart from global, but well, technically that's also a function. But for does not have its own scope, and as such, if we run this code, the console.log is not actually going to log 199. It's going to log 10. The reason it's going to log 10 is because from top down, I is being assigned to 199, and then in the for loop, it's the same I that's being assigned to 0, and when I is 10, it breaks out of the for loop and logs 10 to the console. And this is another example of where hoisting comes in. So this var I is being hoisted to the same line as our var I, and as such, the I inside of the function is the same as the I inside of the loop. Right. Now, let's see what happens if there's an I outside of the function rather than inside of the function. So, say we have a var I equals 20 in the outer scope, and then we are doing console.log I in the first line of the function. We are then doing var I equals 50, and then finally we are doing console.log I. Pretty simple. Now you might think the first line would log 20, because at that point the outer scope variable would be in scope somehow, because I has not been declared yet. But because of hoisting, what's happening is that var I is being hoisted to the first line, and at that point console.log I is logging undefined, and then it's assigning I equals 50. You then get log I logs the inner 50, and then finally, when you're out of that scope, since you're no longer in that function, you're no longer in that scope, the log I logs the outer I, which is 20. Okay? Right. Okay. So hoisting not only applies to variable assignments, it also applies to function expressions. But function declarations are not function expressions or assignments, and as such, they're not subject to these hoisting issues. But that doesn't necessarily make them better. There's issues about scope in this. We'll look at them later. Right. Over here we have another function called add. We've declared the variable add up top. We're logging add12, and then we're assigning add equals function. Okay. When we're logging add12, at that point add hasn't been declared, and because of that you will get an error saying undefined is not a function. Okay. But if you move the assignment of the function to add above where it's being used, it will correctly log 3. In this example, what we have is we don't have a function expression. We're not assigning a function to a variable called add. We are declaring a function called add that takes 2 parameters and adds them. As such, we can actually use that before we have actually declared the function. and as such console.log as 12 would log 3. And notice the difference between this and this. Over here we were assigning the function to a variable, and that would be called a function expression, whereas over here we are declaring a named function called out. So add is available even though it's declared later. Function declarations aren't subject to the same hoisting problems as expressions. The solution to these hoisting issues is quite simple. Simply declare all variables used in a function, including for loops or whatever nested things, apart from functions, of course, at the very first line of the function. So that's called a single var pattern. So if you're using 5 or 6 variables, instead of declaring them in line where they're used, simply do var a, b, c, d, whatever, separated by commas on the first line. Okay. So that brings us to parsing numbers. Now, parsing numbers is quite interesting in JavaScript. There are a number of ways of doing it. We'll look at 3. The most commonly used one is to use something like parseInt. And parseInt actually takes in a second parameter called the radix, and it's the base by which to parse that number. If you don't specify that radix, JavaScript tries to help you. And the way it helps you is that it tries to guess what you intended. So if you pass in 10, you will actually get 10. But then if you pass int 0, 1, 0, you actually get 8. Since it sees there's a leading 0, it automatically assumes that's an octal. Similarly, if you pass 0x10, you get 16, because 0x means hex. As such, if you're doing parseInt 09, instead of getting any value, you actually get 0. It doesn't throw an error, it doesn't return nan, it just returns 0. And 09 is an invalid octal, because octal numbers go up to whatever. So 09 is an invalid octal, and that's why you get 0. But then if you did 09 and as the second parameter you passed in 10, you would actually get 9, because you have then explicitly stated that the radix is 10. There are other ways of converting strings to numbers. One of it is to use the string in a mathematical expression. So if you do var a equals string 09 minus numeric 1, you will actually get 8. It will see that it's being used in a mathematical expression, convert it to a number, and then subtract 1 from it. Okay. But then, if you're adding 2 strings, you get a concatenated string. So you're adding string 09 with string 010, you will get 09010. So what should plus 09 plus 10 return? Here's where it gets interesting. This plus 09 causes this to be passed as a number. So it passes to numeric 9. And then what you're doing is you're adding that numeric 9 with the string 10. So it calls toString on that 9, and you get 910. So the result of this is not 0910, it's 910. Similarly, if you do plus 09 plus 010, you get 9010. That's obvious then, once you know it. But the next one, what we've done is we've done plus 09 as a string, we've added the plus, and then in brackets we've done plus 010. Now this plus 010 causes the 010 to be passed as numeric 10. This plus causes 09 to be passed as numeric 9, and you get the result as 19. But then if you go 3 times 010, you actually get 30. So that's not subject to the same problem as string concatenation with the plus. Right. You might have noticed that when you do a plus 09, it doesn't have the problem with the radix that parseInt had. It always uses 10 as the base. Another approach to parsing numbers is to simply call the function number. And if you do number 09, the radix is used. Sorry, the radix 10 is used. So you get 9, not 0 like you would with parseInt. Out of the three methods, parseInt actually parses using a numeric operation and the number function. They require the whole string to be numeric. If there are some non-numeric characters, it will return not a number, or nan. So if I do plus 20 space ABC, that gives me nan. If I do number 20 space ABC, that also gives me nan. If I do parseInt 20 space ABC, that gives me 20. So you can have trailing stuff when you're doing parseInt, and it will actually pick up the first number. Similarly, if I do the same radix rules apply here. So if you do parseInt 020 ABC, you actually get 16, because octal of 20 is 16. If you do parseInt 20 and then without space you do ABC, you still get 20. If you do parseInt OX20LMN, that passes the hex 20, and then because L is not numeric or not part of a hex number, it just takes the first part, so it does OX20 and returns 32. But if you're doing this, then the moment you do OX20ALM, it actually, instead of giving you 32, the hex 20, it gives you 522, because A can be part of a hex number, or rather A is part of a hex number. So it parses as far as it can using the radix it guesses or you specify. So in this case, it goes up to 20A, strips off the LM, and returns 522. No errors, no nothing, just 522. Right. So the solution to this is simply to be aware of the rules around parsing, so that when you run into a bug, you can see, okay, hang on, this might have actually caused this bug, rather than having no idea what's causing what and debugging for hours on end. The other thing is, don't try to be clever. When you're using parseInt, always specify radix. Okay. The next one is semicolon insertion. So JavaScript tries to be very helpful. If you forget to specify a semicolon at the end of a line, then JavaScript inserts a semicolon for you. It's very helpful that way. So if you do var a equals 20 without the semicolon, it puts it in there. If you do a equals 5, fine. Console.log a will log 5, even though you forgot all those semicolons. It's not an error to omit semicolons. Also, JavaScript is flexible in terms of bracketing strategy. If you're a fan of Kernighan and Ritchie, KNR, you'll put brackets on the same line. C# developers typically follow all none. It's just default in Visual Studio. What that means is that the curly braces start on the next line. So instead of starting here, the brackets start here. JavaScript supports both. So for if statements, for statements, function declarations, you can start the braces on the same line or the next line, completely up to you. Except this might give you some problems. When you're returning an object from a function, like say over here, we're returning a JavaScript object that has name set to John, and over here we're returning It's pretty much the same thing. The only difference here is that the curly brace starts on the next line. Now if you run this, the first one would log John, the second one would actually result in an error. It would say unexpected token, colon. And the reason for that is that that semicolon insertion thing, and JavaScript's attempt to be helpful. So what it does is that it sees that there's a return on this line, and it inserts a semicolon right after it, because well, you forgot to do it, obviously. And then that this JavaScript object that is not used for anything doesn't make sense and causes an error. So the takeaway from that is that use KNR or Orman for every other thing. For returns, consider using KNR. Well, you must use KNR, or brackets starting on the same line. It's typically a good idea to start the brackets on the same line. I follow KNR for all of JavaScript. It's pretty much the convention and standard. Almost all tools that do JavaScript do it that way, so you can do it too. Right, iteration. There are two constructs in JavaScript for iterating over things. One is for, and the other is for in. And a lot of people typically see fors equivalent to for loops in C#, and for ... in as something equivalent to for each in C#. There is actually a difference between the two in how they work. Let's look at the for loop first. It's pretty much the same as what the C# construct would be. So you go var I equals 0, I less than stuff.length I++, seeing that stuff is a collection, like an array or array-like object. And you access the items by doing stuff indexed by I. Pretty standard, quite simple. It might be a good idea to use the single var pattern, so where you're using it, declare I at the very top, so that if the outer scope has, if the same function scope has another variable called I, you're not using the same variable for both things. There is a performance issue here, in that every time stuff.length is called, i.e. for each iteration of the loop, stuff.length will actually be executed. Now that might not sound too bad, but if you're iterating over DOM elements, it can be quite costly. It can be anywhere between, I think the official figures were like between 1.5 times more expensive to several times more expensive, and no guesses for guessing which browser needs several times more time to process it, probably IE, the older versions anyway. But it does cause stuff.length to be called every single time. The way around that is to simply declare max as a variable. So instead of doing this, var I equals 0, I less than stuff.length I++, you can do var I equals 0, max equals stuff.length I less than max. That means your stuff.length will only be calculated the first time and not on subsequent iterations. You do need to be careful when doing this, because if the size of the collection, i.e. stuff.length, changes because you're adding something during the processing of the loop, you'll need to adjust max accordingly. So if you're removing elements, you need to decrease max by that number of elements. If you're adding new elements, you need to increase max. Right. For.in is actually used to iterate over properties of objects, not array and array-like objects. So although an array in terms of JavaScript is also an object, it's typically better to avoid using for-in to iterate over arrays. The reason for this is that if somebody augments the base default library array type with more things, you will get those things in for-in loops as well. Also, the order of evaluation in for.in is not guaranteed. The order of evaluation in for loops is obviously guaranteed. So when should you use for.in? You should use it when iterating over properties of an object to see what properties it has, to do something with it, not for iterating over collections. There is a problem though, is that when you're doing for.in, you will have properties, you'll get returned properties that are part of the object's prototype. So if the object itself has 2 properties and the prototype has 5, you will actually get 7 properties, not 2. The solution to that is, instead of simply iterating and using it, like var item equals something I, you should do a has-own property check. So you're doing for I in something, if something has own property I, and then you do item equals something I, and then do whatever you want with that item. So simply put an if statement with has own property as the first line of the loop, basically. Right. The problem is that some objects, for whatever reason, and this is more for library developers, or writing something that would be reusable across your applications or multiple pages or something, is that something that has own property could be defined by something, could be redefined. Someone could change what it means or what it returns for whatever reason. The solution to that is, instead of doing something that has own property I, you do if object.prototype.has-own-property.call, and you pass in something, and then the I, the index variable. And then that will pretty much guarantee you that you will only get properties or process properties that are added to the object itself and is not part of some sort of prototype. Okay. The problem is that that looks hideous. I mean, it's a huge line of code. If you do that every time in a for loop, that looks ugly. Oh, sorry, for in loop, it looks ugly. You can keep a reference to object.prototype.has-own-property. So over here, what we've done is we've declared a property check variable, and to property check we are assigning a function, object.property.has-own-property. And then in our for each loops, we're simply doing if property check.call something I. Still kind of muddy, but a lot better than this, and it will still work as well expected. So the solution to the 2 iterations and when to use what: use loops for arrays and collections. If you do need to iterate over properties, use for in, and only then when you do need to iterate over properties. And then use a cached version of has-own-property off of the object.prototype, not the array, not the object you're iterating over. You can seriously consider writing a helper function for this, and avoid augmenting basic types like object, array, and function. This can be very tempting to do. Simply adding some extension methods or extension method-like properties to object and array and function, calling them for everywhere. But if someone doesn't know that those things have been augmented, they can cause various logical errors that are quite difficult to track down. Right. The next one is regarding this. And, well, this and scope, basically. We have 2 blocks of code. The first one is an object. P is an object. You get name assigned to John. Say hello is a function that logs hello, my name is this.name. And obviously that should log John, right, when you call p.sayhello. The second one does the same thing, but does it in kind of a roundabout way. So you've got name John, but then say hello is a function, and in this function what you're doing is you're declaring a variable var f equals function, and then doing the same thing, console.log hello my name is plus this.name, and calling that function. So instead of simply calling console.log over here, we've wrapped it in a function called f and executed that function immediately. just by looking at it, if you think logically, these two things should result in the same output. But the first one outputs John, the second one gives you an error. Why does this happen? The reason this happens is that in any function, this refers to the object that the function is a member of. Okay, if something is not a member of something, it's a member of the global object. For browsers, that's document.window. And if a function is not a member of an object, this will refer to the global object. So if you look back at this example, you can see that this function in P is a member of the object say hello. But in the Q example, this outer function is a member of Q, but the function F, that's not actually a member of any object over here. It's not a member of Q. It's a function expression that's been assigned to a variable within the scope of this function. Okay, and as such, this inside the inner function does not refer to Q, it refers to document.window. And since it's document.window, q.sayHello gives you an error, because Q does not have a method called sayHello anymore. Oh, sorry, my bad. Q does have a method called sayHello, but console.log, hello, my name is this.name, the document.window does not have a name. So it does not have this.name, and as such it tells you there's an error, as in hello, my name is John, it can't find a property called name. If you add a global variable called name, then this would obviously work, but that global variable would be referenced. Right. We can change what the context, i.e. what this is going to be inside of a function, by instead of calling the function directly with brackets, like we did here, say hello, instead of doing that, what we can do is take that function and use either call or apply. The first parameter to both is the object that will be this. So this will refer to whatever you pass in as the first parameter, and the second parameter would be the arguments to that function. If you use call, you can pass in a single argument, a single object. If you use apply, you pass in an array. So if you have a function that takes, say, 3 parameters, you can use apply. The first parameter to apply would be the value of this, and in the array you would pass in the parameters you want to pass to that function. So that way you can kind of control the scope under which that function executes. Right, now we'll look at something that's fairly common. It's callback functions. So you essentially take in a function that, a function that takes in a function and uses that function, i.e. calls back. We have 2 objects, slightly difficult to see here. You can think of the middle of the page as a separator. There's the processor object on the left and the person object on the right, or rather constructor on the left and the constructor on the left. Right. In the first one, in the processor function, you're declaring a message equal to the parameter, and then you're returning an object that has a greet function. That function takes in a callback and returns the message concatenated with the result of the callback. Okay, quite simple. The second function, person, simply returns an object that has a name that's the same as the name passed in, and the getName function that simply returns that name. Okay. And over here we are executing that. So we're going var p equals person John, that gives you your first object. You then have var proc equals processor hello, that gives you your second object, and then you do console.log processor.greet, so we're calling that function, with p.getName, so we're calling this function, we're passing that function as a callback. Now we would expect that this over here, since it's part of the same object, would refer to this object itself, so you've got this dot name, which would be John in this case. So you might expect this to log hello John, but it doesn't. It prints hello, not hello John. And the reason this happens is that the this does not refer to the person object when the callback is called, it refers to the global object. Now we need to force what this will be when the callback is called, so you can use either call or apply. And you need to take in the object that this should refer to. So in this case, what we need to do is, instead of simply taking in the callback, we also take in what the context should be, and then we do callback.call context. Right? So we're specifying that this within the callback should refer to whatever is passed in as the second argument. So if we do var p equals person John, and var proc equals processor hello, console.log processor.greet p.getName p, we get what we expect, as in it prints hello John. Okay. But then we need to specify p twice, which can look slightly ugly. We're doing proc.greet p.getName and p, two things that are essentially the same value. Well, two p's in there. Okay, so instead of doing that, what we can do is this. We can check if the type of the callback is a string, and if it is a string, we can say callback is the callback property of the context object. Okay, and what that lets us do is pass in something that looks like this: proc.greet getName, comma p. So instead of doing p.getName, comma p, we're simply saying the getName function of the p object. So p will be the context and getName will be the function. So the solution is that to this problem is that whenever you're taking in callback functions, never call the callbacks directly. Use call or apply, and also take in the target, so that this is what the other object expects it to be, rather than the global object. Right. The next one is about executing code that is in the form of a string. And the easiest way of doing that is eval. And we've all heard that eval is evil. We'll look at why eval is evil and how we can get around that. Okay, so what eval does is it takes in a string of code and simply executes it. It executes it in the same scope as the eval is in. So if we have this bit of code where we've done var a equals 20 and eval var a equals 30, var p equals 50, when we call that and log a and p, we actually get 30 and 50. So what's happening is that even though the code inside of eval has declared var a and var p, it doesn't get its own scope. If the parent container happens to have a variable of the same name, it takes over that variable. So that can be kind of dangerous. Right. One way around that is to wrap any call to eval in an anonymous function. So what we're doing here is that we have the same thing, var a equals 20, and inside of an anonymous function we call eval and execute that anonymous function immediately. So we've got eval var a equals 30, var p equals 50. Now if we log a, you'll see that it logs 20 as expected, this value, and if we log p, p is undefined. The reason for that is that the variables inside of eval are now scoped to this anonymous function and not the outer scope, so it can't mess about with variables in the outer scope. But it still has access to outer scope variables. It can read the values. So when you've got var a equals 20, and if you do eval console.log a in an anonymous function, so it has its own scope, you still get 20. It still logs 20. So the point is that eval, even if you control it with an anonymous function in a local scope, it can still be evil. You should avoid eval pretty much at all costs. If you must execute code that is in the form of a string, consider using the function constructor. Function only sees global scope, so it can't interfere with local scope. So if you do this, where we've got an anonymous function that we're executing immediately, within that function we have var a equals 20. If we do new function console.log a and execute that, you will get a is undefined because the function does not have access to a variable called a, because the scope within function, i.e. within this bit of code here, is the global scope. The scope within this function is completely hidden from it. And then what happens if we do this? Same thing. If we're doing var a equals 20, and then over here we do new function a equals 50, if we log a, and then we log a outside of that scope. First one logs 20 because this function is invisible. A is invisible to this bit of code here, this a. The fact that the function executes a equals 50 does not change the value of this a. So you do console.log a, you will still get 20. But since this executed in the global scope, what this has done is added a variable called a to the global object. It's now a global variable. So when you do outside of that scope, when you go outside of that scope and do console.log a, it's actually calling the global a variable that was created when this code executed. So that logs 50. So you can see that when you're using the function constructor, the function couldn't modify the value of a in the caller scope. All it could do was create a new global variable called a. That might be a problem if there was already a global variable called a. You should probably be avoiding that global variable anyway. The solution to this, string execution thing is that don't use eval. If you must run code from strings, use function. If you know beforehand what that code is going to be, there's no point in using a string. You can just write that function anyway. For parsing JSON, don't do eval, don't do function. You can just do json.parse, which is in most browsers these days. And if you happen to be on a browser that does not support it, you can include a JavaScript library called json2.js. Alternatively, if you're using jQuery, you can simply do $.parsejson, and that would parse the JSON, ensuring all the scope and that sort of thing is maintained. Right. The next problem is with array constructors, and this is another really weird thing about JavaScript. If you pass a string or any object to the constructor of array, you get a array with that element as the only element. Okay. So we can expect that console.log a.length will be 1 and a0 will be foo. Right? So if we do new array 5, we should expect that that would have an array with 5 as the only element. So b.length should be 1 and b0 should be 5. Similarly, if we do new array 5.1, we can expect that the array would have 1 element, so the length will be 1 and the only element would be 5.1. However, if we run this, we get this. Sorry, we get this. So in the first case, it works as expected. So you've got logs 1, and that logs foo. In the second case, you get b.length equal to 5, and b0 is undefined. In the third case, you actually get an exception that says invalid array length. What's the catch? Well, thing is that the array constructor, if you pass a non-numeric to it, it will create an array with a single element. If you pass a numeric to it, as long as it's integral, it will create an array with that many elements, but all of the elements' values will be undefined because you haven't specified them. If you pass in a numeric that is non-integral, like 5.1, it just says invalid array length because, well, you can't create an array of length 5.1. So the solution to this is to not use the array constructor. Simply use the array notation that JavaScript provides. This is, var b equals in square brackets foo is the same as calling new array with foo, and var a equals square brackets 1, 2, 3 is the same as newing up an array of 3 elements and then assigning the values manually. The square bracket syntax is more concise, has the same effect, and is not confusing like the array constructor is. Right, so that brings us to pretty much our last one. This is slightly longer than the other ones. It's object constructors. Right. So over here we have a function called person, and when you new up a person, what happens? So we're doing p equals new person John. That John gets passed in through the name. This dot name is assigned to John. This dot say hello is a function that logs console.log hello this dot name. So if you do p equals new person John and p dot say hello, you get what's expected, i.e. logs hello John. But if you forget the new by any chance, if you do p equals person John as opposed to p equals new person John, when you call p dot say hello, you get an error. Why do you get an error? But then, if you call p dot say hello, if you call say hello anywhere within the function or outside of the function, it actually logs hello John. Now this is interesting. Over here, you're doing p equals person John, and you call p dot say hello, you get an error. But if you call say hello by itself, it actually does log hello John, and you don't get an error. And you even get that outside of p's scope, outside of the function that p is declared in. Why does this happen? Next, if you have p and q, and you've done p equals person John and q equals person Stuart, okay? In the global context, or anywhere, after you've called p and q, or called an anonymous function, if you do say hello, it actually logs hello Stuart. So what happened to hello John? And what's going on? So here's the thing. If you forget to use new when calling a constructor function that's expecting new, this inside the function refers to the global object. It doesn't refer to the object itself, you know, the thing you're newing up. Right, before you go on, just cover this slightly. Right, so when we're calling person without the new, what's happening is that John is getting passed into this function, and then this refers to a document or window. So effectively, you're declaring a global variable called name and assigning it to John, and then you're declaring a global function called say hello, which has this body that looks up this, which is also, you know, global name, and that's what it logs. And as such, when you do p equals person and q equals person, John and Stuart, when you're calling say hello, that calls say hello of, well, the global object, which has now been assigned to Stuart, because at that point this dot name is Stuart. Right. Okay. Now, there's more fun in constructors. Consider this example, where we've got a function called person, and we say this.name equals name, and it returns 25. Next, we do p equals new person John, and console.log p. Now, you can see that the function person is assigning this.name to name, but it returns 25. So you might assume that console.log p would log 25. That actually logs the person object with a name equals John. It does not return 25. Or rather, the value of p is not 25. It's an object that has a property called name, which is assigned to John. However, instead of returning 25 as we did here, if we return something like this, where we're saying this.name equals name, and we return an anonymous object where name is I am not plus name, what's going to happen? We do p equals new person John, so John comes over here, this.name equals John, and we're returning name I am not plus name. Remember, in this case, when we're returning 25, we simply got this object back, so this.name was John. Whereas this.name over here is John, but the name property of this anonymous object is I am not John. And when we log it, we actually get I am not John. So in this case, we get the object back, i.e. this object back, rather than 25. In this case, we get this anonymous object back, rather than whatever is in this. Why is that happening? When called with new, a function that doesn't return anything or returns a primitive object, i.e. an integer or a string, that returns this, whatever this is. So in this case, what's happening is that we're returning a primitive 25. As such, the return of this function when called with new is the this object, not 25. But if the function returns an object, then that object is returned. In that case, it returns an object, so it returns that and not the value of this. Okay. Now, there are two solutions to this kind of confusing thing around constructors, and especially the one with the new is quite quite easy to fall into. You've got a class, and sorry, not class. JavaScript doesn't have classes. You've got a person constructor, and you forget to use new, and it ends up what's it called? It ends up being part of the global object, and it messes up everything. And it doesn't give you an error. It doesn't tell you anything, but it messes up something else that will cause something to break somewhere else. Right. So one solution to this, well, the most obvious solution to this is convention, is that if something requires new to be used, i.e. it's a constructor function, it has to be capitalized. Nothing apart from that should ever be capitalized. So if you don't need new to be used, that function, that constructor function, should not start with a capital letter. It should start with a small letter. So that's kind of a convention-based thing. But that doesn't prevent you from missing the new somewhere. So one approach to that is to simply forget about this, forget about new, and do this. Yeah, I don't know if I should be using the word this so much, because this is confusing in JavaScript. Anyway, so you've got var that, and you initialize that to an empty object, and you go that.name equals name, and you return that. There's no notion of this in here, and there's no confusion as to whether new is to be used. You just forget about new, you forget about this, you just use this approach with that. Right. What this means is that whether you use new or not, this will always give you the same result because you're returning that, i.e. this little thing over here. You can actually use this to create object hierarchies. Douglas Crockford shows a few ways of doing that in his book JavaScript The Good Parts, which is a very good read, highly recommended. But we won't go into the object hierarchy thing today. The drawback to this is you lose the prototype. And in JavaScript, what a prototype is, it's like a template from which objects are created. So if you've created some objects and you add some properties or methods to a prototype, all the objects you previously created would still have those properties and objects. It won't be that only new objects from now on would have that. All of them would have it. But if you use this approach, you lose that prototype. That could be a good thing, because I mean, this and prototypes can be confusing. If you choose to avoid it, good for you. If you like prototypes, that's still fine. The second approach lets you retain your prototypes, stick to the prototypical approach rather than the functional object approach, and do this. In the constructor function, in the first line, what you do is you put a little check in there. You go, if not this instance of person, i.e. that constructor function, then you return new, and then you do your regular processing. So if someone happens to forget to use new, what's happening is that they're passing in that parameter, say John in that case. It comes here and sees that this is not an instance of person, it's an instance of the global object, or rather it is the global object. And as such, it then returns a new person, and since it's using new, the context is going to be correct of this over here, and anybody can then use this with or without new. This has the benefit that it maintains the prototype, but it also has the drawback that you have to worry about other this things and the weird issues that prototypes bring. Up to you which approach you use. Right, that's pretty much the end of it. It was 10 weird things about JavaScript, and if you're interested in looking more into these weird and wonderful JavaScript things and understanding more, then you can read these two books. They're not huge JavaScript books, they're not complete reference books, they're not 200 or 500 pages. The Good Parts is just over 100 pages. It's a very quick read, and JavaScript Patterns is also quite thin, and it is also very useful. And with that, that's the end of the presentation. If you have any questions, just jab at me.